A warm welcome to everyone. In the previous sessions, we had discussed about the D2D communication and what do you mean by D2D synchronization? What do you mean by D2D standardization, that is 4G LTE to D2D? So, what are the two different synchronization operated in a synchronous way where the synchronization source can be either eNode B1 or a UE, that is eNode B1 is nothing but a user equipment which is connected to the base station. UE is nothing but an user interface which is not under the network coverage or in case of intercell operation. So we also came across what do you mean by 4G, what do you mean by LTE in 4G, and what are the technologies which is used in 4G for transmission. Next, what is LTE, what is 4G, and the D2D from 4G to 5G. So in today's class, in the previous class, we started with D2D synchronization. Now, why we require all this is D2D for establishing a D2D connection. So to establish a D2D connection between a device and a device, so these are the following procedures which it has to undergo. Okay. So the first one is D2D synchronization. So synchronization, at least the following issues need to be solved. That is synchronization signal design, entities acting as a synchronization source, and criteria to select or reselect the synchronization source. Okay, as you can see that, this is an eNode base station, that is eNode B, that is the base station, and this is the downlink and this is the uplink. So this is between device to device communication, which is known as the side link. Okay, day-to-day is supposed to cover critical use cases, that is out of coverage communication, relying for extended coverage, communication in case of network failure. Okay. Next, what is the side link synchronization signal composed of? Even this we went through in the previous class. That is primarily side link synchronization signal and the secondary side link synchronization signal. Assuming the UE, that is user interface, have network coverage, then the eNode B transmits primary and secondary synchronization signal that are reused for D2D synchronization. Next, new side link synchronization sequences, which are transmitted by a UE acting as synchronization source. Such UE can be in or out of the network coverage. Okay, both eNode B and UE can act as synchronization sources. However, in order to facilitate inter-cell D2D operation under certain conditions, for example, at the cell edge, UEs with network coverage can transmit synchronization signal as well. In simple words, what happens is first, what is the side link synchronization signal composed of? Is the question here. Now, primarily side link synchronization signal and the secondary side link synchronization signal. Okay, side link synchronization signal consists of primary side link synchronization signal and the secondary side link synchronization signal. Okay, now what do you mean by primary synchronization side link synchronization signal and what do you mean by secondary side link synchronization signal? That is what it is here. Okay, assuming that UV, that is the user interface, has the network coverage. Okay, then the eNode B transmits primary and secondary synchronization signal. Both primary and secondary synchronization signal are transmitted by the base station only. Okay, if the user interface is under the control of or under the network coverage area. Okay, and that are used again for D2D synchronization signal. Next, new side link synchronization sequences which are transmitted by a UE will act as a synchronization source. Okay, new side link synchronization sequence which are transmitted by a user interface will act as a synchronization source. So such UE can be in or out of the network coverage area also. Okay, now both eNode B and UE can act as a synchronization source. Okay, however, in order to facilitate intercell D2D operation, what do you mean by intercell D2D operation? So if you can see here, this will become an inter network D2D operation. Okay, it will become an inter network D2D operation, for example cell edge. Okay, so Under certain conditions, for example, at cell edge and intercell D2D operation, UEs with network coverage can transmit synchronization signals as well. Okay. In case of partial coverage, so sometimes what happens is one device will have the coverage and one device will not have the coverage. So in that case, what will happen? So in case of partial coverage, uh, in case of partial coverage, where some D2D user interface are with network coverage and the rest are without the network coverage. Okay. So as I said, few UEs are with the network coverage and few UEs will be without the network coverage. Next, synchronization signal transmitted by the user interface within the network coverage can also help the out of coverage synchronization by allowing the out of coverage transmission to the cellular network timing. Okay, as I said, partial coverage means few user interface will be with the coverage area and few network coverage, and few interfaces will be having no coverage. Okay, that is the will not be under the network coverage. So at that point of time, synchronization signal transmitted by user interface within the network coverage can also help the out of coverage synchronization. Okay, by aligning the out of coverage transmission to cellular network timing. In this way, the possible interference from D2D transmission to cellular links can be reduced. Okay. In order to solve the potential issue of synchronization source, selection and reselection, different types of synchronization sources are specified with the different priority levels. Okay. The E node B has the highest priority order, followed by in coverage user interface and then out of coverage user interface that are synchronized to in coverage user interfaces. Okay. Now, as we have seen here, what it says is in order to solve the potential issue of synchronization source, okay, synchronization source, selection and reselection process happens. So for this, different type of synchronization source are specified with different priority levels. So each synchronization source is provided with priority levels. Okay. So why those priority levels are assigned? So the priority levels are assigned. Different types of synchronization sources have are specified with different priority levels. Okay, that is the base node, that base station, that is E node B, has the highest priority. Okay, order follow highest priority order followed by in coverage user interface. That is the user interface which is in the network coverage of the base station has the highest priority for the synchronization. And the second priority comes for the out of coverage user interfaces that are sync uh, to in coverage user interfaces. So this is what it is. See, this is in coverage with the base station. So this has the highest priority for synchronization, but this has the second priority of the synchronization because it is not directly connected to the base station, whereas it is connected to another device which is in turn connected to the base station. Okay. The out of coverage user interface not synchronized to any in coverage UE has the lowest priority. Okay. So if suppose this is not synced with these two are the devices. Now this device is also not synced with the base station. Then these two will be having the lowest priority. So first priority is given to the device which is in connection with the base station, and second priority is given to the device which is in connection which is in sync with the device which is connected to the base station. Okay. So hope everyone has understood this. Now next topic is D2D communication. Okay. So what happens in D2D communication and why it is very important? Okay. Next, D2D communication is based on physical layer broadcast communication. Okay. D2D communication is purely based on physical layer broadcast communication. So the physical layer broadcast solution is used to support broadcast, multicast, and unicast services at the application layer. So the physical layer, that is the physical layer, a physical layer broadcast communication solution is used to support mainly the broadcast. Broadcasters, while you have to broadcast certain information, that is, one is the source of the information, and it is broadcasted to, or it is um, it is spread or it is conveyed to other user interfaces, so that is called as a broadcast. So we will be getting the broadcasted, I mean the television is broadcasted. Okay, so that is how it is broadcast. And multicasters, various devices will be connected. Unicasters, from one device, one source to the device. Okay, yeah, broadcast means one source will be there and many receivers will be there. Okay, so if this is the case here, so this is one source is there and many other receivers are there. So this is a broadcast. So unicast is this simple one to one. Multicast is between one device, this one between one device, receiving and transmitting. This is M2M. So this will be multicast. Okay. So the physical layer broadcast solution is used to support broadcast, multicast, and unicast service at the application layer. In order to support multicast or unicast, the targeted group ID for multicast or user ID for unicast is indicated in the higher layer message. Okay, that means while broadcasting or to support multicast and unicast, the targeted group, that means the specific user interface number, okay, or ID will be present in the message itself, in the higher layer message. Okay, next, since by construction it is a broadcast information, no physical layer closed control loop exists. Okay, since the construction of the D2D is for to broadcast the information, so no physical layer for closed control loop will exist. Okay, no physical layer feedback, that is no link adaptation, and no HARQ is supported for D2D links. Okay, so as I said, in the construction it is mainly used for broadcast, so it doesn't have any kind of physical layer. So if there is no physical layer feedback, then there will be no link adaptation and no HARQ supported for D2D. What do you mean by HARQ now? So HARQ stands for Hybrid Automatic Repeat Request. Okay. So HARQ stands for Hybrid Automatic Repeat Request. That is, HARQ is ARQ plus FEC. That is forward error correction or soft combine. ARQ refers to the automatic repeat request. That is, if the sender doesn't receive acknowledgement before timeout, the receiver discards the bad packet and sender has to retransmit the packet. Just like your um, Bluetooth. If you're transferring a file from one device to another device, so the other device has to authenticate it, okay, or acknowledge it. If the receiver or the sender will not acknowledge the message at that point of time, what happens? The message will be completely discarded, and again the sender has to retransmit. But this technique is not available in D2D. Why? Because it doesn't have a why it doesn't have a physical layer. Okay, next, the air interface, that is the interface between the device to device, is based on the UU interface and UL channel structure. Okay, which is extended to D2D communication. So what do you mean by UU interface? UU interface is nothing but a radio interface between the mobile and the radio access network. UU interface is nothing but the interference radio interference between the mobile and the radio access network. Okay, now the air interface is mainly based on UU interface and UL channel. Okay, so this is very important. All those things you have to write in your exam. Okay, UU interface and UU interface and UL channel structure. Okay, which is extended to D2D communication. In particular, for D2D data communication, related physical channels is reused whenever is possible. How we reuse the physical channel, that we'll be seeing in the coming slides. This is how we will be reusing the physical channel. Okay. Considering resource usage, D2D communication is based on a resource pool concept. Okay, so this is called as a resource pool concept. So you can see it here, resource pool for D2D data communication. Okay, resource pool for D2D control information and transmission. Okay, so these two are used for data transmission and these are used to for the control information transmission. Okay, considering resource usage, D2D communication is based on resource pool concept as shown in the figure, where certain time or frequency resource called resource pool are configured for D2D usage. Okay, the D2D resource pool is configurable within one cell, and there are separate resources for D2D control information transmission and D2D data transmission. The resource pool information is carried over broadcast message, that is typically it will be in this format: system information block type 18. Okay, so considering the resource usage, D2D communication is based on what? Resource pool concept. So what do you mean by a resource pool concept? So this is a resource pool concept as shown in the figure, where this and this, okay, this and this is used for data transmission, whereas these channels are used for control information of the transmission. Okay, where certain time of frequency resource, that is called resource pool, are configured for D2D usage. The D2D resource pool is configurable with one cell, and there are separate resources for D2D control information transmission and D2D data transmission. The resource pool information is carried over a broadcast message, that is the message will be in this format, that is system information block type 18. Okay,